Okay, we're going to explore this notion of variability of means with an applet. So I select sampling distributions, and we'll start with the bell-shaped distribution, and we'll just take the defaults, mean of 25, standard deviation of 5. Okay, so here is our normal, this is our population at the top. And suppose we're going to select a sample of n equals 30 from a population that has a mean of 25 and standard deviation of 5. What would we expect the mean of the sample to be? So we expect this to be pretty close to 25. So I'm going to take one sample. So here's our sample, and it's shown in this middle graph. And then the mean of this sample is plotted on the bottom graph. And the mean of this sample is 26.3429. And since we just have one sample mean down here, the median is the same. Let's select another sample. Again, we're going to select one time. Notice what happens. Most likely, you're going to get a different sample mean. I got 25.7531 in this case. And again, it's plotted in the green at the bottom. Let's do this 3 more times and notice what happens. So I have a total of 5 samples here. Yours is going to look a little different. Notice that each sample produces a slightly different sample mean. Again, these sample means are being plotted down here on the bottom in green. I'm going to take samples now at 5 at a time until I get to a total of 100 samples. Again, my sample size is 30, and that's plotted here. So there's 10. And again, we can see 10 down here. And kind of notice what's happening. So what sort of observations can we make here? How would you describe the shape, center, and spread of this distribution of sample means? Looks like it's normal, bell-shaped. The mean is at 24.9494. Standard deviation is at 0.9013. The values range from, looks like around 22 to about 28. I can click on this little plus button here. It'll give me some more of the data. Here's my minimum value at 22.5, maximum at 27.19 or so. Even gives me some other values here I can drill into. Now take 1,000 samples at a time until you get to 10,100 samples. Okay, so notice I have 10,100 samples. How does the mean and standard deviation of the sample means compare to the mean and standard deviation of the population? So I have a mean of 25.0043, very close to 25. The standard deviation is 0.916, which is very close to 5 divided by the square root of 30. So I really encourage you to play with this, explore what happens when you adjust the sample size and its effect on the sampling distribution of sample means. You can increase the sample size to 60 or 120, decrease it to 15 or even 5. And we played around with an applet similar to this with sample proportions. Now I want to select a skewed distribution. And let's do a right skewed. So I'm going to come up here to Options, Edit, and I'm going to check Right Skewed. And I'm going to leave the sample size here at 2, and I'm going to take 10,000 samples with a sample size of n equals 2. And what do we notice about the distribution of sample means? It's also right skewed. I now want to increase the sample size to n equals 5. And again, let's take 10,000 samples of size 5. So this distribution looks more normally distributed. Also note the standard deviation is smaller. We would expect variability among sample means decreases as n increases, as we've seen before. Let's increase the sample size to n equals 20. And again, we're going to take 10,000 samples of size 20. So we really see that the resulting distribution of sample means, it's getting to be more normally distributed. This is a very, very powerful result and is called the central limit theorem, or CLT. It states if you can keep drawing larger and larger samples, calculate their means, the sample means form their own normal distribution, the sampling distribution, regardless of its parent population. We can actually create any kind of distribution with this applet. Simply just use your mouse and sort of carve out any distribution you want. Let's try this one. What happens when our sample size is n equals 2? So let's change this back to 2. I can even bump it up to 10,000. It does not look normally distributed, does it? We can definitely see 3 or 4 peaks in the graph. Now let's change the sample size to n equals 20. Whoa, what happened here? I'm going to bump it up to 10,000. Isn't that amazing? Was that expected? Hey, this looks much like a normally distributed curve. It underscores the central tenet of the CLT, the central limit theorem. As the sample size n increases, the distribution of sample means will approach a normal distribution.